In this video, we're going to convert between grams and moles. We're given a quantity in grams, and we want to convert to moles. So again, we start with what we have, 54.9 grams of beryllium. We set up the proportion. We want to cancel the unit we start with. We want moles, so that goes on top. And this is very similar to the last video. The proportion is just flip-flopped. This time, my 1 mole goes on the top, and my mass from the periodic table goes on the bottom. So I look up beryllium, 9.01 grams. Grams and grams cancel. We divide. And again, I can see if this answer makes sense. I have about 54, 55 grams of beryllium. Each mole would be 9 grams. So if I divide, I'm expecting something around 6. 6 moles. My original has 3 sig figs. So I plug this in my calculator. 6.09. I was expecting around 6. It makes total sense. I think the key to these mole calculations is not to try memorizing each type of calculation. If I switch from grams to moles, I divide by this. If I go from grams to particles, I go by this. Instead, get this proportion method down. It will never fail you. Start with what you have, and you have to put the unit in with the number. 973.03 grams of platinum. Then I set up my proportion. If I know my original number is in grams, I want to cancel grams, goes on the bottom. The unit I want, moles, goes on the top. Whenever I see mole, it's always a 1. Whenever I see grams, it's always off the periodic table. 195.08. My units should cancel so that the only unit left is the one that you want. This time again, I divide. Yikes, this first number has, 5 significant figures? So we'll leave 5. 4.9879 moles. Which kind of makes sense. I have a little less than 1,000 grams. Each mole is a little less than 200 grams. So yeah, I'm expecting a little less than 5. If these were multiple choice, I bet you could even pick a reasonable answer without using your calculator. Use your noggin. Both of these I could estimate without a calculator. So again, these are very similar. We're just starting with the mass, converting to moles. At this point, again, I would suggest pause the video. Try a few of these that involve compounds where you do need to write the formulas to get the molar mass. Then bring it back and see if you're on the right track. If you're getting these right, you're really in a good place. All right, here they are. Number 1, make sure you got the formula right. If you don't have the formula correct, then obviously your molar mass is not correct. But that's why you show all of this work. Show me the formula that you used. Show me your proportion that includes your molar mass. Diphosphorus pentoxide is one of those covalent compounds. You don't need charges. You can just use the prefixes to find the ratio. P2O5. 2 times phosphorus plus 5 times oxygen. You do not need to show me work on how you calculated the molar mass. Just show me the proportion with the molar mass you used and your original formula. We divide. The original had 4 sig figs, 0.7426 moles. Not bad, huh? Number 4. The chromium 4 hydroxide. Chromium's charge is +4, hydroxide is -1. So when I calculate the molar mass, I need chromium plus 4 times oxygen and 4 times hydrogen. And then we divide. Again, my original this time still had like 5 significant figures, so I left 5. And number 5, my lithium phosphate. There should be 3 times lithium, 1 phosphorus, 4 oxygen. If I add those together, I should get a mass of about 115.79 grams. And we divide. So this makes sense that my moles is pretty small. I left 2 significant figures. Those leading zeros do not count as significant figures. If you are getting these right, I have a good feeling that the rest of this chapter will go really well for you. If you find that you're struggling at this point, maybe stop by for a little help, a little mole intervention. Make sure that we're on the right track before we go any further.